What is angular acceleration? How did we represent angular velocity? Through the symbol omega. The moment of inertia and radius of gyration. F is 10, so 20 pi radian per second. I was mr square when it comes to radius of gyration. Hello students, it is SD sir again from the Temple of Excellence, Vidhyaashram Pre-University, Mysuru. We have completed our sessions, the theory sessions on the chapter System of Particles. I expect you have gone through these sessions. If you have done so, solving the problems become very, very simple. So today we will understand and solve problems from the chapter System of Particles. Very simple. Few expressions, if you are familiar with, simplifications are dead easy. Oral simplifications you can say. So let us start solving the problems. Calculate the angular velocity. How did we represent angular velocity? Through the symbol omega. So calculate the angular velocity. In the first case, seconds hands of a clock. Angular velocity of the seconds hands of a clock, and B, the minutes hands of a clock. So two parts in this problem where you are asked to calculate the angular velocity. In the first case, with respect to seconds hand of a clock, and next minutes hand of a clock. So in the first case, seconds hand. So I'll calculate the seconds hand of a clock. First, angular displacement is 2 pi radians. I am calculating angular velocity in terms of the seconds hand. Angular displacement is 2 pi radians and the time is 60 seconds because it is the seconds hand. So what is omega, students? How did we define angular velocity? It is nothing but angular displacement by time, 2 pi by 60 radian per second. See, very simple. That is what I told. If I know a few expressions here, solving becomes very, very simple. The next, similarly, I will have to find the angular velocity of the minutes hand. angular velocity of the minute's hand. Again, theta is 2 pi radians. Now what is T? It is 60 into 60. Yakandre minutes alide. Converting into SI seconds. So 3600. Again, omega is theta by T. 2 pi by 3600 radian per second. Dodi, very simple. Did I use any rocket engineering here? 5th, 6th standard physics. Simple expressions, easy to solve. Next one. A wheel of radius 0.3 meter rotates at 600 RPM. In RPM andre rotations per minute. Calculate the angular velocity in radian per second and also calculate the linear speed of the dust on the rim of the wheel. Now, the radius of the wheel is 0.3 meter and it rotates at 600 rotations per minute. Notice very clearly, 600 rotations per minute. So frequency is 600 by 60 per minute irodrinda. So this is 10 hertz. What is that initially I will have to calculate? Angular velocity. So what is angular velocity in terms of frequency? 2 pi f. F is known. So 2 pi into 10. So 20 pi radian per second. See, very simple. So I have calculated omega, which is angular velocity, 2 pi f. F is 10, so 20 pi radian per second. And also, we have to calculate linear velocity v. Given radius, how will we find out linear velocity? V is r times omega. So 0.3 into 20 pi, nearly 18 meter per second. So if you are observing, it is very, very easy to solve problems from this chapter, provided we know the concepts. Now, the speed of a body, rotating body, increases from 120 RPM to 240 RPM in 20 seconds. Find its angular acceleration. What is angular acceleration? Alpha, rate of change of angular velocity, which is omega 2 minus omega 1 into t. Angular acceleration ಕಂಡುಹಿಡಿಬೇಕು. Frequency is increasing from 120 rpm to 240 rpm in a time interval of 20 seconds. So angular acceleration will be omega 2 minus omega 1 divided by t. Therefore, initially, what is omega 1? 2 pi f1, which is 2 pi 120 by 60. Why? Because it is in rotations per minute. Again, I am calculating and converting in rotations per second. So this goes twice. So this is 4 pi radian per second. Omega 2 pi f2, 2 pi 240 by 60, which is 6 pi radians. So alpha 6 pi minus 4 pi divided by 20. This is 2 pi divided by 20. So many radians per second square. Finished. What time did I take to solve? So if you know the expression, solving the problems here is at the twick of your eye. Next one. A body of mass 5 kgs. There is a body of mass 5 kgs acquiring an acceleration of 10 radian per second square. Body of mass 5 kgs acquires an acceleration of 10 radian per second square by a torque 2 Newton per meter. Calculate the moment of inertia and radius of gyration. Nenpidiya? Gyrus center. So mass of the body is given 5 kg. Angular acceleration alpha is 10 radian per second square. And torque is tau is 2 Newton meter. With this first, how will I calculate moment of inertia? Always remember, when alpha and tau is given, angular acceleration and torque is given, tau is always I times alpha. Please know this relation between torque, inertia and acceleration. Tau is I times alpha, or I is tau divided by alpha. So 2 divided by 10 kg meter square. Now I know what is I. I want gyration. So B, I is m k square. I was mr square. When it comes to radius of gyration, k is replaced by r. So k square is I divided by m. Take the root, you get radius of gyration. And the same way, the last problem, this will be your assignment. A ballet dancer spins about a vertical axis, making 60 rotations per minute with her arms stretched. Ballet dancer spins about a vertical axis with a frequency 60 rotations per minute with her arms stretched. When her arms are folded, her moment of inertia decreases by 40%. When he says decreases by 40%, the moment of inertia retained is 60%. What is the new frequency of revolution? So it is very simple. See, in this case, I1 is the initial moment of inertia, I1. What is I2? It decreases by 40% of I1, or I2 is nothing but 60 by 100 of I1. ಯಾಕೆ 40% ಡಿಕ್ರೀಸ್ ಆಗಿದೆ, ಉಳ್ಕೊಂಡಿರೋದೆಷ್ಟು 60%. Omega 1 is 2 pi f1. 2 pi f1 is 600 by 60. Again 10. Omega 2 is 2 pi f2. Now, how will I find f2? Law of conservation of angular momentum. Omega 1 is equal to omega 2. Substitute, you will get the answer for f2. So in this way, students, little bit of expressions, familiarity with the concepts, you can easily arrive at the answers. In my next session, I will work out few more problems from this chapter. Until then, have a nice time. Practice. Thank you.